Hi, everyone. Welcome. Thank you for joining. This is the Oracle Autonomous Database Learning Lounge. I am Marco Senesibi, a part of the product management team for Autonomous Database. And today we have a very, very special session. We're going to be talking about basically streaming, right? So everything to do with the Oracle Transaction Event Queues, everything that is connected to Kafka, for example, right? So Kafka streaming, messaging platform, how we can work with the compatibility with that, and how you can actually take advantage, right, of this component that is already built in the database, right? So we're going to have Anders Swanson, we have Becca Kogabasoglu, and then Nitin Tekupadan Narayan, and they're going to be showing us all of these different topics, right, related to how to use the Oracle Kafka connectors, and then how to eliminate the need for Kafka clusters, for example, right? So they're going to be doing a demonstration, and then they're going to be doing some slides for you guys to understand the concept, okay? So before we begin, this call is for you, so make sure to type your questions in the Q&A section in Zoom, okay? And we're going to share some links for you guys in the chat, all right? The recording of this session, slides and all that is going to be available at the link that you see below there, okay? And speaking of links, here are some of the links I'm sharing with you guys right now. So you should see in chat the links related to how to get, to know Autonomous Database, our live labs, how to get in touch, all of the different social media platforms, and also in the external Slack workspace that Oracle developers have. We have a channel there. So if you need to speak to us, ask your question there, you can easily type it. Just search for the Oracle-Autonomous-Database channel, and you can post your question there, and we're going to be ready to help you guys with anything that you need. All right? And again, thank you for joining our session today, Nitin and Ben and Anders. I'll stop sharing. I'll let you share your screen, Nitin, and please take it away, and thank you.
All right. Hey everyone, thank you so much, Marcos. Hey everyone, I'm Nitin. I'm a Senior Principal Product Manager at Oracle. And today I want to talk to you about Transactional Event Queues. So today we'll have our session focusing on interoperability with Kafka and how you can run your ADBs with Kafka using Transactional Event Queues. And we'll have two interesting demos. But before getting into the demos, I really wanted to introduce you to what Transactional Event Queues are and why you should be using it, and some integrations and compatibilities that we have, followed by demo by Anders and Ben. So before we dive into Transactional Event Queues, I just wanted to touch upon event streaming in general. So basically, event streaming systems are services that helps two systems communicate by acting as an intermediary for message exchange. So primarily, these systems involve a message broker of sorts, and I see that a lot of folks are familiar with Kafka, OCI, streaming, and RabbitMQ. And the key goals of a messaging system is to ensure that the communication happens without both systems needing to be online at the same time. And those messages follow a specific structure for consistency. And it has to ensure that those messages are being delivered to the destination which is desired. And of course, for a durability standpoint, you need those messages to be stored somewhere so that it can be recovered reliably. And very, very important aspect of messaging systems are it should be able to handle high volumes of messages so that your systems or your services can scale and does not cause these messaging systems to be a bottleneck. And there are plenty of messaging systems out there. You called out Kafka, RabbitMQ, and there are a ton of cloud services as well that offers messaging service, and Oracle being a key one of them. And messaging or event streaming systems are generally used for two forms of communications. One is the synchronous and then the asynchronous. So synchronous is basically a request response system which relies on the recipient systems to provide a response before the subsequent steps of the operation can proceed. It's usually stateless, and it's very tightly coupled because there is that dependency, which makes it really difficult to scale. And the blast radius can also be high because it could cause cascading failures. Whereas the asynchronous system, it's more resilient because it does not depend on the recipient system to respond. So it can scale independently, both the producers and consumers. which makes it scalable and highly decoupled, but they are very complex to implement, which makes it harder to manage and monitor as well. So a general rule of thumb or recommendation would be to use synchronous system for public interfaces and async systems for communication in your internal event-driven architecture. So that's where transaction event queues come in. So Autonomous DB introduced transaction event queues as a part of Oracle 19c. Oracle already had advanced queues, and transaction event queues is actually an enhancement to its capabilities. And I'm sure a lot of you are familiar with advanced queue. It's been around for more than 10 years, which started out as a basic queuing system, and transaction event queue aims at improving and has improved its capabilities. And a lot of customers use transaction event queues to implement geocoding and routing, health record systems in hospitals, e-commerce processing, personalized marketing, enabling agile infrastructures, and a lot of IoT systems. So these are one among few of the very popular use cases we have seen customers using transaction event queues for. So what is transaction event queue, right? So transaction event queue is a feature that combines pub sub and point-to-point message within the ADB at no added cost. I want to double click on that. It can be deployed on ADB, on-prem, or anywhere where you run your Oracle database. It is highly compatible with Kafka, which you will see as a part of the demo at the later part of the session. And it supports multiple languages, interfaces, and data types, which makes it ideal for polyglot development. It allows event streaming and DML to be combined in a single local transaction, which a lot of messaging systems don't do, and would require added setup to achieve that. And it guarantees exactly one's delivery, and it's completely ACID compliant, which also a lot of messaging systems are incapable of today. And overall, it reduces your development efforts because it offers a rich messaging set of functionalities, which otherwise you would have had to build on your applications. So how do we achieve this high performance and scale with transaction event queues? So it is basically the sharded architecture of transaction event queues that allows you to scale both vertically and horizontally across cores or instances. And its in-memory implementation can handle billions of messages a day. And combining that with the redesigned queue tables and the use of messaging cache, it can offer really high performance because it reduces a lot of database operations which otherwise would have been required, such as indexes and so on. And it supports real-time monitoring using Prometheus and Grafana. So that comes with the package. And the benefit of transaction event queue being a part of the database is that it inherits a lot of features or the goodness of the Oracle database, such as backup and recovery, and more importantly, the security features. And there are some special features such as propagation that helps you consolidate messages for recipients without overloading certain queues. So there are a lot of features that you can try out on transaction event queue, which would definitely help you stream better with limited overhead. So I wanted to touch upon, I saw a lot of 50% of the team does not have event streaming workloads. So here are some common challenges that event streaming systems can encounter and how transaction event queue can help mitigate it. So barrier to entry. So for those who haven't gotten started, this is something that I constantly hear from customers. Getting into event streaming can be a little challenging because of the expertise that is required and the infrastructure investments one has to make. But transaction event queue, since it is already just a feature within the ADB, you require no additional infrastructure cost. And these are predominantly database functions which you can easily ramp up on. So that reduces the expertise that requires for you to build them, or the need for expertise rather. And two-phase commit, it's a very well documented problem for Kafka as well. So Kafka is currently working on a KIP to implement support for two-phase commit or 2PC, which makes coordination across messaging and database fairly complex. But transaction event queue does atomic writes, which helps prevent this 2PC problem, and its in-memory implementation ensures that its performance is not compromised. And like I said earlier, security. So in an event streaming system, if you have a separate event streaming system, there are more endpoints, which means more security vulnerabilities. But transaction event queue, since it is a part of the database and inherits all the security features, that is one less thing for you to worry about. and data divergence and loss. So even small data inconsistencies between two systems over time can lead to very expensive mitigation steps. But transaction event queues ensure this consistency and integrity through that exactly once delivery and transaction support, which eliminates this problem for you. And asset properties. So messaging systems generally prioritize throughput over strict asset compliance. Yes, which is a healthy trade-off to make. But a lot of customers who care about data governance need these asset properties. So transaction event queue adheres to all these asset properties since it's a part of the database itself. And like I said earlier, it comes with a rich set of messaging features which are built into transaction event queue assets properties, both on the producer, which is NQ, and the consumer, which is the DQ side. I'm not going to get into the details of all this in the interest of time, but I will share this deck with you, and I strongly encourage that you try these out and let us know how you feel, how you think about it. And today, in the modern application development world, gone are those days when database was just relational, and as and when it's evolving into adding more data types like JSON, spatial, vector, and so on, the type of data types that a DB has to support has increased, and so have the workloads such as analytics using machine learning and graph have evolved. So the good news is Transaction Event Queue supports all database that ADB supports, and it has a rich support for a lot of languages and APIs, which helps you minimize the need for multiple applications in order to run it. And for you to run this in your database, ADB's Converged database architecture is your answer to run modern applications. So think about Converged database as a smartphone of data, right? It supports all possible data types within a single database. And in order to use multiple data technologies, you do not need to use separate products. It's just a feature within the database. And to use different data types, to stream different data types, you just need to add a queue instead of adding a messaging service altogether. And since Transaction Event Queue, again, is a part of this Converged database, so you do not need that separate messaging platform to run your event streaming platforms. So now let's look at some integration. There are wide variety of integrations available, but I've just picked two in the interest of time and the most popular ones. So one is the Spring Framework. It's the most popular among the Java developers to manage your dependency injection and transactions. So Transactional Event Queue offers two ways in which you can manage or integrate with your Spring framework. One is through the Spring Cloud Stream Binder API that helps you seamlessly integrate with Transaction Event Queue, and the Spring Starter Kit for JMS and Kafka that provides pre-configured templates and settings that can help you reduce the efforts that you would need in order to get started with the Spring framework integration. And the interoperability with Kafka, which is, of course, the theme of the day. So there are a variety of ways in which you can integrate or replace Kafka using transaction event queues, which you will see in the demo, either using the connectors or the Java APIs. You can directly connect with Kafka or eliminate the need for even a Kafka cluster if you want to run your event streaming workloads on Oracle. Having said that, I want to wrap up this presentation and leave time for Anders and Ben to showcase you how Kafka interoperates with transaction event queues over the demo. But before I leave, I just wanted to touch upon a few key takeaways that I want you to remember. So one, transaction event queue is not a product. It's a feature within the ADB, which comes at no added cost. It's highly scalable because of its in-memory, it can scale across rack on your database, and it's high performant and can be enabled on any cloud as long as you have an Oracle database. It enables modern application development because it supports variety of data types and APIs. Its rich messaging features can help avoid a lot of redundant development that you would otherwise have to do on your applications. And it offers exactly one semantics and asset compliance being a part of database. So a lot of less things for you to worry about when you're operating event streaming on Oracle. So that wraps up my presentation, and I have added a bunch of resources that can help you get started, including a live lab. So feel free to try this out and reach out to us in case you have any questions. I have also added, how you can raise a ticket here and how you can reach us through support. So that's a wrap from my side. I'll hand it over to Anders.
Cool. Get started here. So I'm going to be showing a fun little demo that demonstrates how to migrate an Apache Kafka application to Oracle database using transactional event queues instead of Apache Kafka for event streaming. So here we have a little Java application that uses all the Kafka APIs. And we'll go through these 3 steps where we replace our Kafka libraries with Oracle database libraries. We'll do some live coding to update a few classes. It's only a few lines of code to use the Oracle database versions of stuff rather than the Apache Kafka versions. And then we'll change our connection properties to point to Oracle database. I'm using Autonomous Database for developers here instead of an Apache Kafka broker. Before we do that migration, let's look at what the Kafka app is currently. It's a very simple Java application, but it uses all of the main APIs of Kafka. And that's the admin API to create and manage Kafka topics. It uses the consumer API to receive messages from a topic, and the producer API to publish messages to a topic. That's what this main method here is doing. And I have a Kafka broker running on my machine that I'm going to run this app against, and we'll see what's printed out. And this is relevant because once we migrate the app, the behavior of this application should be unchanged. So when the app starts, we create the topic. In my environment, the topic already exists, so it's essentially skipped. And we start the consumer and the producer. The producer publishes 10 messages, and the consumer receives all those 10 messages, and then we wrap up the application. So it's very simple, but it does use all those important APIs that you're going to see in a more enterprise class application. So to start the migration, we're going to take the oKafka dependency. This is Oracle's Kafka Java client for Oracle Database Transactional Event Queues. We're just going to copy this and drop it over in our POM file for the project. Right now I have the Kafka clients dependency. I'm just going to replace that with the oKafka dependency, and I'll resync my dependencies, make sure everything's good. All right, now we'll do the next step, which is any admin client or consumer or producer in my app, I'm going to replace with the Oracle database version rather than the Apache Kafka version. So let's go over to the app and the place where I create my topic. I'm going to replace this with the admin client from oKafka. You can see the import string there uses oKafka from org.oracle package. Same thing for the producer. Let's do the oKafka producer instead of the Kafka producer. And lastly, my consumer. We'll use the oKafka consumer there. And when I scroll up to my imports, we can just verify that I'm using the Oracle versions of these clients, but the rest of the imports and the rest of the code is unchanged. And this is because these clients, while they connect to Oracle database, they implement the Kafka interfaces that are supplied in the Java Kafka clients package. So the rest of my code that creates topics, consumes messages, produces messages is totally unchanged. And then my last step is I need to update the application connection properties to point to Oracle database. This snippet here is for plain text because I'm using Autonomous Database for developers. I'm going to use the SSL version of the connection properties. A few things to note here. We have a couple Oracle specific property keys, which let me specify my TNS alias and also the path of the database wallet. I'm using MTLS with my database instance. So I've already downloaded the wallet onto my machine and put it in the resources directory of my Java application. And I pass that resources directory as the oracle.net.tns admin, which is where all my JKS files, PIM files, all those wallet-specific files live. So let's copy this and go over to our connection properties here, replace this method, make sure we have import this file class, and then I'm going to supply my TNS alias, which is SDB high. And that's it. My application will now use Oracle database instead of Apache Kafka. And we'll go ahead and run that again. Just verify that it worked. So we'll compile our Java code, start our application, and see what we get. So the topic also already exists in Autonomous database. I produce 10 messages into that Autonomous database Kafka topic, and then I wait for my consumer to receive all those messages. So if you remember the application behavior when we were using Kafka, it's literally the same. That's because we're using the same APIs, same interfaces, but when those messages are produced and consumed, they're going to Autonomous database. They're not going to Kafka anymore. And that's because we changed those connection properties, we changed that dependency, and the application is now fully migrated over to Oracle database. All right, that's all for that demo. It's very straightforward migration. Easy to do. This code, you can find it on GitHub, and I'll share a link to that code in the chat so you can play with it yourself. Vin's up next.
All right. Thank you, Anders. We're doing the live coding on the presentation. I know that's really hard, and I'm definitely not going to do that because I'm not the courageous. Okay. All right. So for the demo, in my case, we wanted to build a kind of like a real world use case where we can kind of show how things are going to be moving in an environment where you have Kafka clusters and then ADBS database with the transactional event queue, and then kind of mimic a real world scenario. So in this scenario, you can kind of think of it as like this is a e-commerce company enterprise, and what they do is they basically have a bunch of partners, and these partners are selling their products online, and you can kind of assume that this is a Java service that will basically be receiving the orders coming in, and then the blue one boxes here are sales organization, and they have a different infrastructure, different systems, software, and everything else. And they're using Kafka in this case. And when this Java service receives orders, it is going to be placing to a topic called orders on the Kafka cluster. And so let's assume that we are the supply chain organization down here, and we're using Java, but we are not using the Kafka cluster. And since we are using Oracle database, we wanted to leverage the transactional event queue so we don't have to manage another infrastructure. So with that, we basically are going to be using transactional event queue sync Kafka connector. And with that, it will be near real time receiving the orders that's coming into the Kafka cluster and sending to our orders Kafka transactional event queue that is on the our Oracle Autonomous database. And then after that, we have a Java service, order processing service. It will be receiving the orders coming in, and then it will go to our product inventory table, and then it will look at the product ID and pull that information from the table. It will check the our stocks, and it's going to validate it. If everything looks valid, and if we have the order product in stock, then it will basically produce that event to the ready to ship topic that is in transaction event queue. And we have some other services that will basically take it from this point and then, send it to the client, send the notification, and vice versa. But let's assume that there's not enough products. In that case, we are going to be sending to another transactional event queue topic called orders to reconciliate. And according to our processes, we will basically handle those separately. So for this, as you can see, we need to have Java services. we need to have a Kafka cluster that is running on an environment, and we need to have autonomous database. So for this, what I ended up creating is for the Kafka cluster, I built a Docker Compose, and all this code is going to be available to you all afterwards. And I'm just going to be creating a Zookeeper, as you all know. And then we have our Kafka cluster. And then we have our Kafka Connect cluster starting. So let's go ahead and then go to terminal and then look at all of that. And then if I go to my local, and then look at all of them that is running, as you can see, here, just ignore this one. This is not running. It was me testing some other stuff. So we have our Red Panda console. That is actually just to kind of visualize some of these things that I'm going to show you guys. And then we have the Kafka Connect 7.5 running. And then we have Kafka 7.5 running. And then we have our Zookeeper running. So that has been up for the last 13 hours. Okay, so I know, sometimes having visual things makes it a lot easier. So just for that, this is an open source tool where you can just connect to any Kafka cluster and kind of visualize what's happening. As you see, we have the orders topic here. It has 3 partitions. And if you click on that, you can see the partitions, if there are any active consumers, and you can kind of see the messages that I kind of produced before the demo to make sure that everything is working. Also, I can go to Connect here, and if I go to Kafka Connect section, that will actually show me my Connect cluster. If I go here, you can see that I have a Transactional Event Queue orders sync connector that is running. It has 3 tasks, and all of the tasks are healthy. And let's see, anything else? If I click on this, then you can also see that like what are the connector types are actually supported on this Kafka cluster. These 2 are the ones that I basically deployed to this cluster from our jars. Okay, that's what we have locally. Now, let's go to our database so that I'm looking into another screen here. All right, so for the database, I didn't want to run the database local because this is autonomous DB session, right? So I have this 23 AI autonomous database running on my OCI compartment. And this is a transactional processing. Everything else, let's see, general, but I only have like 4 eCPU and 256 gigabyte of storage. All right, so let's move on. Next thing is, if you look at our diagram, the order creator service. So let's get order creator service code. This is our code. I'm not going to go into code since I only have 20 minutes and I already burned about 8 minutes. But high level, what this does is we're using Kafka library. This one is actually just the Kafka library. We are basically, if you look at here, this is the order creator service. It will basically be producing orders into the Kafka cluster. So what I ended up doing is I just got the Kafka client libraries installed, and then I have a utility that will be generating random orders based on the records that we have in the database. And I have an input util. Input util is basically allowing me to just like hit enter. It will generate 1 record. If I say 100, it will basically generate 100. If I say bulk 1,000, it will basically produce 1,000 orders. And then it will basically do a bulk publish to the Kafka topic. So I have this one as handling that. And then the next thing is our order processing service. And in our order processing service, we're using the autonomous database. And here, we are initializing our data source and then our consumer and producers. And then we basically start consuming, and we basically give a list of topics that we want to subscribe from the transactional event queue. And then every 1,000 millisecond, it will basically consume a batch of ready events. And then after that, it will basically go through, check the product ID, go to the database, pull the product inventory, and then it will check if we have enough in stock. If we do, then it is going to deduct it from the inventory, and then it's going to run an update statement on the database table. So, this is a real-time environment, right? There's like a lot of orders coming in. So we need to make sure that we're not handling multiple orders at the same time and end up like processing 2 orders and not having enough. So this is going to be handling that part. And then for the enrichment part, this is kind of like real-time processing. I just wanted to put this in here. So we're actually doing the calculation of the total amount of the order here, and then we are putting into the event. And then we are producing to the orders to ship. In case we do not have enough in the stock, then we are going to be basically sending it to the orders to reconcile topic, and then we're going to be putting out like saying that like, hey, you didn't have enough. Yeah, that's basically in a high level. Let's go back to our diagram. So that was the order process service. Just to kind of visualize like events coming into ready to ship and ready to reconcile, I basically wrote 2 consumer applications in Java that kind of mimics that. So orders fulfilled. I mean, this is literally just a Kafka consumer using Oracle Kafka library, and then it is consuming the orders to ship topic, and this is orders to reconcile topic, and then it will just basically show us when the order kind of goes into that spot or get published to that topic. Okay, let's see. All right, so this is kind of infrastructure, and then the code. What else do we have? I'm going to go into the PL SQL part. This is kind of like showing the topics that we have here: orders to Kafka, orders to reconcile, ready to ship, and then table that we have for the product inventory. So normally, on Kafka cluster, depending on which instance that you use, you most of the time use either the command line, or if there is a console, you go to their console and then just create a topic, right? So similarly on our Oracle database, you have multiple way of creating it, but I picked the PL SQL approach where I basically just say create a database Kafka topic, and the topic name is orders Kafka. And since we have the 3 partitions on the Kafka cluster, let me go there so we can kind of remember. So it has 3 partitions. So I'm basically following the same thing. I have the 7 days of retention on the message, and then assignment mode is 2, and there is no replication for now. So when you execute this, it will basically be creating the Kafka topic. Since I already created it, I'm not going to do it. But if I do it now, it'll probably say, hey, you already have it. Yeah, no, it's already there, right? Okay, the next one was the order to reconcile. Really similar. I basically have 3 partitions, 7 days retention. And as if the traffic is not enough, or if you don't have enough scalability for the traffic that's coming, we can always increase the number of partitions. And the same thing for the Kafka topic. So that's pretty much it. And for the inventory table, I just basically created this table. And for dummy data, I basically had this random script that will generate like 100 products and then just put it into the table. Let me do a quick time check. Good, we have 7 minutes. All right, so if I go to the product inventory and then do a select star, so I can show you guys what we have there before we run the application. All right, let's do star, product name. All right, so these are all the products that we have. And as you see, some of the products have 400, 200, 700. So, and there's the unit price. This is the one that we basically use to calculate. All right, in the demo, I'm gonna go ahead and like update like first 50 of them to only have like maybe like 10 record to 10 products, so we can actually get it to the point where we don't have enough items in the stock, so it can basically go to the other part. Okay, now let's go to the demo part. Oh, actually, before I jump to that, I wanted to show the sync connector configuration. I know that like only 40% of the audience here is familiar with Kafka. If you're done, this is basically pretty much familiar to you, but if not, I'm just going to quickly go over this. So when you're creating a Kafka connector, it's basically a JSON configuration file, and every connector basically has their own special properties, and also it inherits from basic base Kafka connector libraries as well. So this is Transactional Event Queue sync connector, and this class is basically, I'm telling the Kafka Connect to use this jar to actually create this. And since we have 3 partition, I basically have 3 max, so one producer or consumer for each one of them. And then the topic that we're going to be consuming from is orders. That's basically the name of the topic that I have on the Kafka cluster. So now this part is kind of the Oracle part. So if you have an ADB, as you all know, you have the wallet. So I'm using the wallet path, and then I'm selecting Ali's name. And I'm basically given the target topic name at the transactional event queue. So my transactional event queue name is orders Kafka, and I'm using the string converters. And then this is the Bootstrap server for the Kafka cluster. Okay. Now let's go into actual demo where this is running. All right, so kind of set this up in a way that hopefully this is going to look nice. That in IntelliJ, I have all the apps running here. So this is the Kafka order creator service. So as you see, if I basically hit enter or put one message, right, that will basically generate one order. So this is the order that it generated. I'm using the timestamp for the order ID. It picked up a customer ID, and then status, product, and then the number of units that we are going to be processing, and vice versa. So cool part is here, I can just say, I want to do 10 orders, then it's going to generate 10 orders. Okay, so this is basically in the diagram where we generate the orders. Okay, there's my diagram. Let's move it here. This guy right here. Okay, this is orders not fulfilled, and this is orders fulfilled. So orders fulfilled, this is the ready to ship topic, and this is just a consumer that will show me that, like, we process and produce to this topic, and then this is what we see. And not fulfilled is basically this one. And then here, order processor server, this is the one right here. So I basically picked the balanced provisioning, which means that I have the same amount of services running equals to the number of partitions on the orders Kafka topic. Since we have 3 partitions, I have 3 of them running. And if you look into the logs here, you can actually figure out like which one is what as well. So let's see, where is that at? To move to the right. So this is like partition 1. Right? If I move to the right a little bit more, you can see that this is partition 0, and this is partition 2. And our Kafka event key is basically customer ID. What that means is orders that is associated with that customer will be distributed across different partitions. All right. So now let's do a little bit more else. So if I hit 1, as you see, event actually got produced with the customer ID 13. And then you can see that this was written to partition number 1 on the Kafka. And then order processor that was looking at the partition number 1 picked it up. It consumed it. So we processing order 60, product ID 65. You can see that 65 number of units is 1. And then we are retrieving the product information. Here's the product information from the database. So it's a high performance laptop for professionals. We have 211 in stock, and unit price is this. And then sufficient stock available. So we deducted it and updated it successfully, calculated the total amount, and then we send it to orders to ship. And if you look at the orders fulfilled, the last one should be basically matching to that product ID 65 and everything else. So let's kind of have fun with it. So if I say 10 of them now, right, it will generate 10 of them. And then depending on which partition it kind of falls into, it's going to be handled on different processors. So let's say 25. And as you see, things are moving. And actually, I didn't really need to do the update on the database because we actually found some of them that doesn't have enough in stock. And they basically show up in here. And let's have a little bit more fun. I'll say, let's do 1000. And then this will basically be, processing all that. Quick recap. I think I only have 20 seconds left. So what did we do, right? So if you already have an ADBS, as Nathan and Anders already mentioned, you didn't really need to set up any infrastructure. You already had the database, and you could just basically create the PLC tool to create your topics, and then that's basically it, right? So as we have shown here, I created the topics, and then I basically started to use our Kafka library and then start consuming it. So I didn't really need to create an infrastructure, deal with Kubernetes or partition rebalancing and all the other Kafka related terms. And ADBS and Transactional Event Queue basically took care of all that for me. So that is all I have. Thank you all.
Excellent. Thank you very much, man. That was great. So everyone, so we have the Q&A open. If you guys have questions, we have already replied to many questions. I'll send a quick poll. Just I think many people and most of the folks that were not familiar with the technology learned a lot. In the meantime, again, Q&A is open. We have already answered several interesting questions. Many people asking, how can we use that, right? And then where is it available? So there was a lot of great interaction there, right? Use cases, if they could use it in PL SQL. So again, keep asking questions, guys. In the meantime, we'll leave that open, okay? And we'll keep an eye on that. So again, you can come back and watch the recording, watch the demo, go to all the links that Anders is actually sharing, right, in chat for the different places in that you can see, all the way to the code, right? He's sharing the demos, live labs, right? He's sharing a lot of great resources there, and in GitHub, and we're gonna have all of that in the slides as well, right? When we share it, when you guys come back.
Thank you so much, all. I think we have answered a lot of questions. If we have missed out few, I apologize. We'll try to answer it before the close of this. But few things I saw few interesting questions. I just wanted to touch upon them. So one was about whether AQ and Transaction Event Queue is Transaction Event Queue completely replacing AQ, or can they coexist? So the answer is yes, they can coexist, because you just can create, using the create queues, you can create AQs or Transaction Event Queues. So perfectly reasonable, and they can coexist. And another one was how the resources. So since we had mentioned this is a feature of the database itself, do we need to provision additional resources for Transaction Event Queue? So the answer is no, because Transaction Event Queue shares the memory and the other infrastructure footprint of the database itself. But having said that, this is where messaging can get event streaming can get a little tricky, because if there is a lot of influx in message or dequeuing happening at the same time, it can strain your resources. So it is very, very important that you have good monitoring capabilities in place to monitor your database performance and utilization. So like any other resource intensive services, which could be your producers and consumers, you would definitely need a better handle on your monitoring. And there were questions about how it compares with Kafka. Since this is a database feature versus Kafka being or other messaging service being a different service, there is no real apple-to-apple comparison that we can make at this point. But I would strongly recommend that you based on your use case, you try it out, look at the throughput and the latency that you're getting. so that you can compare yourself how well it is working for your workloads. And yeah, those were a couple of very common questions that I have heard, which I thought would benefit the entire audience. Others, if you found something interesting that you would like to double click on, Anders and Ben, would be great.
Yeah, I saw some stuff about like why you would want to use this instead of some other streaming service like OCI streaming or Apache Kafka. And to me, the main reason here is you can do your messaging, your service-to-service communication within the database, and those messages, they're living in the Oracle table architecture. You can query them with SQL, and you can combine things like produce and consume with other database operations. So when I am producing a message or consuming a message, that data is going through a database connection. And by nature of utilizing that connection, I can do something like update a row or some other type of DML within that transaction and commit it atomically if it succeeds, or roll back the messaging and the DML if something fails. And this is possible with other systems, but it requires a sort of bespoke implementation. Whereas if I'm using a transaction, it's kind of dead simple.
Okay, there was a question from David. I don't see if it was answered or not, but he was asking why handoff to autonomous DB orders queue? Why not go direct to Java order processing service? Advantages of this approach versus using serverless function. I mean, so one thing was, of course, you can have the order service directly consume messages from the Kafka cluster. But if you do that, in the production environment, most of the time, Kafka clusters are going to have encryption. You're going to have to do some onboarding process. So there are some other things that needs to be done to actually just do that, right? When you actually just have the Kafka Connect deployed on the Kafka Connect cluster, and then have the data come into your autonomous DB, you don't have to go through those onboarding processes. But of course, if you don't have that, in your environment, you can always do that as well. That's a possibility. But having the queue on the autonomous database will also give you some additional features and fault tolerance and all other stuff, because you have the full control over the topic that you have.
Excellent.
Thank you. Yeah, I just wanted to close with something since we are almost on time. We are super excited to showcase the Kafka Connect, the connectors to you. But I just want to leave you with the thought that it's fairly new still, and we are constantly working on improving it. So while we would really appreciate you testing and giving us the feedback, I just want to know you that it's fairly new. So in case you see something or would like some improvements on those connectors when you see it, feel free to let us know. I had left the link to support on the deck itself, which would be shared at a later point after the session. So yeah, just want to throw it out there.
Can I quickly address the one about why not use triggers instead of transactional event queues?
Yeah, this is a kind of like architectural difference when you're running like a microservices architecture where you're passing messages between services rather than doing everything in the database. So I have a lot of data processing, data streaming, data modification happening in a chain of decoupled services. And these services pass messages to each other, but they also operate independently, scale independently, and are quite decoupled.
That's right. Yeah.
No, and we have had customers who were using, that's what I wanted to answer this, but I somehow missed out. So we have had customers who have come with the exact same problem. They used to use triggers for processing this data, but it was taking a toll on their database performance, which is why they wanted to move to more queuing systems. But, it all depends on the use case. Ultimately, if it is a simple insert that is coming in and you don't have too much, throughput that is coming through, maybe triggers would be a good option.
Okay. Thank you.
All
Sure.
right. Thank you, guys. Excellent. Okay, so again, thank you. Appreciate all the comments and all the information. Having said that, right now I'm resending, just so that you guys have it. I'm resending the links, right, to the autonomous database resources, just in case you guys did not get them at the beginning. Basically that's it. So we're going to still be doing some sessions that are developer focused, right? So for now, we're going to have around, we expect to have 4 more sessions that are specifically, tailored to developers, right? So you guys keep an eye on the site, on the link that I sent that you can see here on the screen. That's where I'm going to post the links, right, for the upcoming sessions, and you can see the replays of all the previous sessions down here as well. All right. Okay. So that's it. Again, I really appreciate you guys joining. I will leave this call open for a few more minutes. Okay. So I'm not going to end the call. It's going to be open. If you guys have any quick questions, again, please make sure to type them in the Q&A. Okay. Anyway, in the meantime, I again appreciate you guys joining. Appreciate my speakers today and all the details on the session. It was a pretty great session to watch. And if you guys still have questions, please type them in the Q&A. Okay. And see you guys next time. Thank you very much. Appreciate it.
Thank you.
Thanks.